Hey everyone, it's Coding with Kareem, and today I want to make a video on Goroutines. Goroutines are a way for us to handle asynchronous operations in Go. For those who write code in Node.js or JavaScript, you may be used to using the async and await keywords, and concurrency is usually handled through an underlying event loop. In Golang, we actually have concurrency built in into the runtime itself through Goroutines, which are essentially just a lightweight thread. So for those who are also used to writing in C, you may be used to spawning operating system threads, but those can be very, very expensive to spawn. Think of, the way Apache may handle their servers. Spawning a bunch of operating system threads can be heavy on your resources. So Golang actually gives us a way to spawn a bunch of lightweight threads, user space threads that aren't nearly as costly to our system. So before we start implementing these Go routines and seeing how we can actually get utility from them, we're going to look at a synchronous example and see how we can make our code a lot more efficient and fast using Go routines. So in this file, I have this fetch function. This fetch function takes in a URL as a parameter. We're going to make a GET request to this URL. We're going to do a little bit of parsing to read the response body, and then we're going to return a stringified version of the response. We're going to return that, and in our main function, we're actually going to call this fetch function 3 times. We're going to use it to get a collection of singers, cars, and drinks, and I actually have a local server running on my computer, so that's the server that we're going to interact with. Once we get all of the data, we're going to actually assign these values into this API data map. So at face value, this code, seems like it's doing what it's supposed to. It's very simple, but the reality is that we don't need to wait or do all of these network requests step by step. There's no need for us to do that. We can actually run the code from line 12 to 14 at the same time concurrently because there are no dependencies from each network request to the next one. So let's actually use Goroutines to make it so that we make all of these network requests concurrently. So for us to do that in Go, it's very, very simple. All we have to do is add the Go keyword right before calling our function. So we're actually going to do that for each one of these function calls. We're going to add the Go keyword. And in Go, a Go routine will always return void. So you can't really assign a variable as a result of a Go routine. So we're actually going to remove all of this. We're just going to simply call these functions in Go routines. So we removed all the variables, and we also need to remove all of this code because we no longer have the actual result from the server, which will be okay. So now we simply have all of this code running from line 12 to 14. This will make network requests concurrently in its own thread. For us to actually add the data or add the result to API data, we're going to actually have to assign the result within this fetch function. And we can do so because API data is declared in global program space. We could have also declared this locally and passed it in as well. So after line 35, I'm actually going to write API data. I'll use the URL as a key, and then I'll use the result from the server as a value. And that's essentially it. Each one of these Go routines is going to call the fetch function, and once it gets its data from the server, it's going to actually write to this API data map and add a new entry. So that's essentially how we can assign and data and get data from a server in a concurrent fashion. One thing I do want to note though is that API data is declared in global program space and Go routines are spawning their own threads. So we are officially in race condition territory. For us to get around that, we're going to have to implement a mutex. So I'm quickly just going to implement a mutex here. And right before writing to the API data struct, or map, we're going to just write mutex lock, and then after we're going to protect this API data resource. After we finish writing to it, we're going to unlock the mutex. So this essentially just handles multiple threads actually writing API data. If we were just reading API data, it really wouldn't be an issue. So this is a way for us to handle concurrent operations in Go. One thing I do want to note quickly before this video ends is that on the main function, our main thread or our main Go routine is probably going to exit out this program before any of these Go routines finish firing. So for us to actually use API data later once all of this code finishes, we're going to need to synchronize these Go routines. And we can do so using something called a wait group. So in our next video, we're actually going to make some small changes. It's going to be very quickly. We're going to implement a wait group so that we can kind of synchronize these Go routines and use the actual data in API data. So before this video ends, let's quickly run this example. As I noted, because we don't have a wait group synchronizing these Go routines, we probably will have our program exit immediately. We won't really see any logs, I think. Um, so as you guys can see, I kind of ran the program and we didn't get anything in the console, even though I have these print line statements, and that's because our main Go routine kind of just exited out the program before any of these Go routines actually finished. So we will have to synchronize that. I'll see you guys in the next video for us to implement it, and I hope you guys have a great day. Goodbye.